Welcome back to Real Terms for AI. Aja, we've talked about small models and large models. We should probably talk about something else, right?
How about domain-specific models?
Let's do this.
So that everyone is with us, large language models and small language models typically are similar types of transformer-based models. Their size is typically grouped by the number of parameters that a model has been trained on. Some of the largest language models have trillions of parameters, and some of the smallest ones have only a few million. Domain-specific models can be large or small in terms of the total number of parameters. The main difference is how we train domain-specific models. The datasets they use for training are highly specific to a particular domain, for example, finance, or medicine, or coding, and are typically experts in a narrow set of processes or questions.
Depending on where your model needs to run and how much information you need to pass them for input, a domain-specific model could be classified as a large language model or a small language model. For a large language model, you might start from a model like Gemini and then fine-tune for a specific domain based on your input dataset. You can use data to do things like add parameters for domain-specific knowledge, or get specific on classification problems that may exist.
And for a small model, the approach would be similar. Your input data will have to be even more important and have even more weight because the base model has a narrower parameter set. Jason, so let's talk about one of your favorite topics here around trade-offs, cost.
It wouldn't be a complete episode if we didn't talk about it, right? For domain-specific models, we may choose to use smaller models because the cost of inference, that is the prediction, is likely to be cheaper. However, we shouldn't discount the amount of work that it takes to train these models sometimes. First, you'll need data, including sometimes generating your own synthetic data based on your actual data. You also need to pay for the training time and optimizations to make the model fit on specific hardware if you need to. If you're wanting to explore more about how a domain-specific model performs, you might also choose to fine-tune an existing large model first, then optimize to create a small model for that production use.
I'd like to point out that we haven't talked about agents yet, and I'm pretty sure that's against the rules, so I'll fix that right now. Agents and domain-specific models can work really well together, where the agent can complete a specific, specialized task with the help of a domain model. And this is all super abstract, so let's actually use an example. Let's say we're creating an agent that will process invoices for a global organization. These invoices in particular have many specific terms and complexity because that kind of thing happens at global organizations. Using existing data as an example, we might choose to create a domain-specific model that knows all about things like shipping terms, fees, and the other legal and corporate requirements of our company. This model is an expert at invoices and payments. We are trading off generalized knowledge for that ability to be an expert. And since we've created this specialized model, we'll update our agent to use that model for any domain-specific tasks. We might also change some of our agent definitions to make sure it's clear where this agent should be used now that it is specialized.
And we could do this for other domains like medicine. While we obviously aren't the experts in the data required for that field, understanding the use case of a domain-specific model is incredibly important. Then you can use your common deployment patterns for your model type and where it will run. Also, don't forget the application basics here of logging and monitoring and evaluation are still very important. Your prompts and responses are even more valuable in domain-specific models to make sure that your model is truly an expert in what it can accomplish.
So if you have a specialized use case where you think you need a model that is an expert, and you'd like to try this out and see if it'll work for you, we have some links in the description box below that will help you get started with domain-specific models. And with that, thanks for tuning in, and as always,
Happy prompting!